So now here is the our second example is 4.8.3, which is related to combustion of ethane. So first of all, read the question. Here is the question. We can see that here written ethane is burned with 50% excess air. So first information is here in ethane combustion uh, with 50% excess air, and the percentage conversion of the ethane is 90%. Of the ethane burned, 25% reacts to form carbon monoxide, and the other balance reacts to form carbon dioxide. So we have to calculate the molar composition of the stuck gas on a dry basis and the mole ratio of water to dry stuck gas. So first we should think the combustion of ethane. We know ethane will react with oxygen, and the product from will be carbon dioxide, and by the side reaction the product is also from the carbon monoxide. So first of all we should rewrite the equation. Ethane plus oxygen to carbon dioxide plus 3H2O. Then similarly when carbon monoxide formed, then the reaction will be like that. Okay, we should carefully balance the both side, left hand and right hand molecule, because in calculation we must consider the mole ratio, stoichiometric ratio. So you should careful about this. Okay, now we have done the first job, that is the reaction. So we can see that in the ethane burn, some of the ethane react with oxygen to form carbon dioxide, and some of other ethane react with oxygen to form carbon dioxide. So first we should write the flow chart to simplify our question. So now the flow chart will be here. The information is ethane and oxygen or air is coming to the reactor, and the product from will be monoxide, carbon dioxide, H2O, and reacted oxygen and nitrogen and ethane. So the flow chart will be uh, input side to input first C2H6, and then 50% excess air. We know that in air there is 0.21 mole oxygen per mole, 0.79 mole nitrogen per mole. So now the product from will be N1, we think the unreacted ethane C2H6, and 1 mole C2H6, and 2 mole oxygen, and 3 mole nitrogen, and 4 mole carbon monoxide, and 5 mole carbon dioxide, and 6 mole H2O. And this is the product gas is called stuck gas. I know that. And then first of all we have to consider a basis. So let's the basis is 100 mole ethane fit to the reactor. 100 mole ethane fit to the reactor. So this will be 100, and we assume that and not mole air. So first of all, hence is there two reaction. We can solve it by different methods, like atomic balance method, molecular balance method, or extent of reaction method. So first of all, here the information given, first of all we analyze the degrees of freedom, DOF, degrees of freedom, which is number of unknowns minus number of equation. So let's consider here is the 167 unknown, and the number equation it will be 3 atomic balance, carbon, hydrogen, carbon, hydrogen, oxygen, 3 atomic balance, and 1 unreacted nitrogen balance. Here we see that in this reaction there is no any nitrogen participated in this reaction. So one will be the nitrogen balance equation, and the another information, extra information is given that excess air specification and ethane conversion specification, and also the carbon monoxide and carbon dioxide ratio specification. So the number of unknown equal 7 and number equation will be also 7, so we can solve this systems problem, hence the degrees of freedom is equal to 0. So first consider the extra information. Here we see that given that extra information is 50% excess air. So in this sense 50% excess air means we can calculate the theoretical, we can by this we can first we can calculate the theoretical air, and then we can consider this excess air. By this we can also measure the input air rate n naught, which is n naught. So first we should measure the n of oxygen theoretical by this reaction. So if you see this in this reaction, there in the first reaction, for 1 mole methane we need 7 by 2 or 3.5 mole oxygen react. In second reaction, if we in 1 mole methane 1 mole ethane, and this will need 2.5 mole oxygen to create carbon monoxide. So by this here our input feed rate of ethane is 100 mole ethane. When we consider the theoretical oxygen, we consider that the 100% conversion of the reactant, that means ethane, and the 100% conversion, and there is no side reaction. So our main product will be carbon dioxide. So our main considerable reaction is in reaction 1. So in this reaction 1 we see that for 1 mole ethane we need 2.5 mole oxygen to create 1 mole of 4 mole 2 mole of carbon dioxide. So by this we can write that 1 mole ethane will react with 3.5 mole oxygen. By this we can calculate the theoretical oxygen is 350 mole oxygen we need for theoretical oxygen. So here given that 50% excess here. So by this we see that in the flow chart the our oxygen will be n naught into 0.21, which is input to the reactor. So n naught 0.21, n naught into 0.21 is fit to the reactor of oxygen, which is equal to 50% excess. That means 1 plus 0.5 into n of oxygen theoretical. By this n of oxygen theoretical is 350. So there is one equation, one unknown, so we can easily calculate the n naught value, which is equal to 2500 mole air feed rate. So now we can easily calculate the air feed rate in this system. And so we also use the first extra information, and then the second extra information is 90% ethane conversion, which means the 90% ethane is reacted and 10% ethane is unreacted. So in this flow chart we see that the unreacted ethane is n1 mole, so 90% conversion, that means 10% unreacted. So you can calculate that n not equal to 100 into 0.1, which is unreacted ethane. So this will be 10 mole of ethane. So hence we can calculate the n1, which is 10 mole. So by this n1 mole unreacted, and then reacted will be 100 into 0.9, that is means 90 mole reacted ethane. So here also another information is given that uh, from ethane, the 25% ethane reacted to conversion to carbon monoxide. So here our carbon monoxide mole is N4. So N4 will be, here methane is reacted 90% and 25% of 90%, that means 0.25 mole reactant to form carbon monoxide. Mole C2H6 react to form carbon monoxide. So hence also we can see that in this reaction, in the reaction number 2, for 2 mole carbon monoxide produce 1 mole ethane is needed. So by this we can write that for 1 mole ethane reacted, 1 mole ethane C2H6 react 2 mole carbon monoxide generated or form, which is same. So N4 will be, by this calculation, it will be 45 mole carbon monoxide. So we also find out the another variable. Then so we can, now we also used the extra 3 information. We are also used the 25% to form carbon monoxide, 90% conversion of ethane, and 50% excess of air. So we already used the 3 extra information. Now we can, so by this extra information we also we now calculated N1, N4, and N0. So here also 4 variable, for this 4 unknowns, we can equation 4 equation, we need 4 equation. So now we can carbon balance, hydrogen balance, and oxygen balance, and nitrogen unreacted balance, which is unreacted. So first nitrogen balance, which is unreacted, so is input is equal to output. Here input is, output is N3. Here and input is 0.79 equal to N0. So we first calculate that N0 is 2500, that means 2500. By this calculation we find out that nitrogen will be 1975 mole nitrogen. So this is the N3 value. So we also find out the another unknown. Now we need the 3 unknown, by these 3 carbon, hydrogen, and oxygen atomic balance. So first of all, carbon balance. So if you see the flow chart, let me copy that. So now we see that in the flow chart, and the fit rate, the carbon in the fit, the carbon balance. So here in the input, the carbon is ethane, 2 carbons, so 100 into 2 equal to N1 into 2, plus in carbon dioxide, carbon monoxide, that means N4 plus N5. Okay, and now in this equation, N1 already is known, N4 already is known, so the N5 unknown is equal to 135 mole carbon dioxide. So then oxygen balance, in this inputted oxygen and not into 0.21 into 2 equal to in oxygen and 2 into 2 plus in carbon monoxide and 4 plus in carbon dioxide and 5 into 2 plus and 6. So here just n2 is unknown, n4 and 5 and also n6 is also unknown, n6 is also unknown. So there is two variable we can't solve this equation because hence one equation two variable. So you have to need another equation which is hydrogen by this hydrogen balance. So hydrogen balance, it will be 100 into 6 equal to 10 into 6 10 into 6 okay, and 1 into 6 that means plus in 6 into 2. By this equation we can easily evaluate the n6 value, which is 270 mole S2. If we put this into this equation, we can find out the n6 value, sorry, n2 value. So n2 value will be 232 mole oxygen. So now we are already find out the all variable, all unknown, n1 n2 n3 n4 and n5 n5 and n6. By this we just find out the extra gas volume which are produced in this ethane combustion. But the question is the calculate the molar composition of extra gas on a dry basis. So to emit the S2O or S2O water, we have to calculate the molar composition of the gases. So here the N1 and 6 gases, so we have to neglect the S2O for dry basis calculation. By neglecting the S2O, we just calculate the total mole, that means N1 plus N2 plus N3 plus N4 plus N5. Then we have to calculate the composition for these 5 gases. For C2H6 ethane, this composition will be N1 divided by total mole, and for oxygen it will be N2 divided by total mole, for nitrogen N3 divided by total mole, and by etc. By this we can easily calculate the molar gas composition of a dry basis. So this will be this method for solving this problem. Thank you.